Okay, welcome everybody. I'm Igor from the Angular team. Welcome to our January meetup. Today we're going to have a really cool presentation from guys from OpenTable. And before we do that, I have a few announcements. Angular 1.3, there are a bunch of releases that happened in the last few weeks. 1.3 releases focus still primarily on bug fixes and documentation updates, while 1.4 beta releases add new features. If you're interested in 1.4 and see what we are doing there, please check out the blog post. The link is in the slide deck. And we are planning to release 1.4 around March, so it's coming soon. And if you want to 2014. Okay, that's wow. Okay, sorry. 2015. I should have said 2016. That would give us a little more time. Okay, in March, there's another interesting event happening, ngConf. The ticket's already sold out, but there's going to be live stream of really cool presentations. So if you want to watch, you can watch online. You can just go to ngConf website to find the live stream. But there's also a better way to watch the live stream. The organizers of ngConf are also doing something called ngConf Extended. It's a way for you guys to organize local groups to watch the live stream together. This is targeted primarily for companies that have lots of Angular developers, as well as meetups and just people who are interested in watching the live stream together. So if you are interested in more information on how this can be done, there is a swag involved and local activities. Visit this link and you'll get information about how to participate. With that, this is the link to the slide deck if you want links to other things I talked about. And I'll hand it over to Sarah.
Hi, my name is Sarah Rahimian, and I'm an engineering manager for OpenTable's restaurant platform team. I'd like to welcome you to tonight's Angular meetup. Thank you for joining us. We have an exciting talk for you guys this evening. We are a team of web developers who have been developing a series of rich applications for our restaurant customers. Over the last 2 years, our application has evolved from vanilla JavaScript through various frameworks until we settled on Angular over a year ago. Then in May of 2014, we attended a Polymer presentation at Google SF, which offered us a new view of our UI layer. We loved the evolution of web components as a natural extension of HTML for web application development. Tonight's talk is our journey through that paradigm shift as it applies to the Angular framework we were already using. I'd like to introduce Rachael Moore and Kara Erickson, our speakers for this evening, as they share with you the motivations and implementation journey towards UI components. Rachael is a UI engineer focused on the CSS and HTML side of these components, and Kara is a web engineer helping us leverage Angular to create custom UI components. Before they start, I'd like to ask that you hold questions, and though it may be hard to resist applause, until the end when we will have a lightning talk followed by some QA. So with that, thank you. Welcome, Kara.
Hello. All right, hi everyone. So before we dive into the talk, I wanted to give you all a brief outline of what we're going to cover in the next 45 minutes. So the talk breaks down into two parts. First, we're going to talk about the basics of reusable components. What are they, why it's so beneficial to use them, and how to design them. And then we'll use our own OpenTable application scaffold to demonstrate how to break an existing application down into its components and reconstruct it using a component-based architecture. On the way, we'll compare 3 different models of directive design: transcluding content in multiple points of one directive, using attributes as a sort of component API, and taking advantage of subdirectives. In the course of explaining these patterns, we'll also delve deeply into 2 foundational concepts you need to understand inside and out in order to build successful components: transclusion and isolate scope. For many of you, these concepts will already be familiar, but they're especially important to review because what seems simple in one component built in a vacuum gets more and more complicated as you start building these components on top of one another and nesting transcluding components and other transcluding components. So even with 3 moderately simple components, you might end up with a scope hierarchy like this. So during the course of the presentation, we'll be working up to this scope diagram. So that's your outline, and now I'll hand it over to Rachel. Rachel?
So at OpenTable, we split our products into 2 phases, one for restaurants and one for diners. And since almost no one here probably owns a restaurant, behind me is just a video of what that looks like. So our restaurant team is currently converting a large, feature-rich legacy system for restaurants into a web application called Guest Center, which is a growing application with a large backlog of features. We noticed that since the functionality of those features is really self-contained because it's all highly task-specific, we could get really great results if we approached our product as a series of microsites or an app made out of apps created and maintained by small teams. But for that to really work at the scale that we need, we have to have really seamless and hopefully painless integration between those applications for our own sake, because I don't like to be miserable at work, but more importantly, because we have to have a consistent user experience. There can't be any hiccups in the users navigating through the product, even though different teams might work on different parts of the application in entirely different repositories. So one way we can achieve this is by creating reusable user interface components. And so what is that exactly? Well, if you think about it for a moment, graphical web user interfaces are this chimeric combination of script, style, markup, assets, text. And currently what we have in most UI libraries is a bunch of separate files that we're hoping people will combine as we intend and or to their own satisfaction. And each one of those separate files may use language-specific component practices. But we currently lack any way to ensure that all of this code that's required to work in concert actually does so. Ideally, what we would want is something that can combine all of these pieces associated with the user interface. AngularJS directives do this for script and for HTML in ways that fit really well within an already Angular application. So it's a really good place for us to start to use these in production while learning concepts that will be useful to us in the future. Because when we create these user interface components, we gain a number of benefits. Reusable user interface components allow application developers who are building products to quickly implement consistent user interfaces. This means that our distributed teams can provide a seamless user experience, even when the application is actually a patchwork, in much less time. At the same time, UI components hide the complexity and all of these implementation details of admittedly non-trivial UI widgets, allowing product developers to focus on writing code for their features, speeding up development. On top of that, UI components create a kind of inherited expertise by packaging up all of the animations, assets, and refinements that the UI designers have labored over to create high-quality, engaging user experiences, improving the overall quality of our applications. A component-based UI library also improves the process of updating existing applications with design changes and with bug fixes. Deploying an updated UI component can update all of the applications using that component while keeping the change code isolated from the rest of the application's code, improving the speed and reliability of our releases. And just like the JavaScript function as a unit, UI components help us to do one thing with repeatable accuracy. They become our user interface unit. And because of that, we boost the reliability of our code by narrowing down its purpose, and therefore what to test. This improved testability also increases the quality of our application. Which brings me to the psychological benefit of working on an isolated component. It helps component creators concentrate on really nailing that component's code and design. Just like not having to worry about the component's code helps the product developers, leading to faster and better development. And using Angular directives specifically or something else like them. And there are some exciting alternatives coming that use web components, as well as some compelling improvements coming in Angular 2.0. Has a few more tangible benefits that are incremental improvements over many existing solutions. Custom elements, for example, have several advantages over the method of copying and pasting HTML snippets. With custom elements, we're able to write markup that's specifically applicable to our business requirements. To use fancy words, we are able to create a domain-specific declarative language. That declarative style means that when we're using the UI component, all of the supported configuration options are in one place, and they can be changed in one way. There's no mystery about whether an option needs to be changed in JavaScript, in CSS, and HTML, or a combination of all three. So hopefully you're super on board with the premise that UI components are awesome and that making them is time well spent. So where do we start? What elements are we going to need? And how do we know that we're making them the right way so that they can go out into the world and be the component that we really meant for them to be? Well, there are quite a lot of things to keep in mind when designing UI components. So I'll go over some of the overarching ones now, and then we'll go into a little more detail later on some of the others. So the first one's the elephant in the room, because you know what? Maybe we don't even need to give this talk. I can probably teach you how to become a UI component expert with this one weird trick. Framework developers will hate me. Stalk other frameworks. I mean, do your research and find inspiration in prior art. If almost every UI library in existence has a component that you could use in your app after a few revisions, well, it's probably something you're going to need, and it's definitely done in a way you can learn from. But moving on to doing things yourself, one thing to keep in mind when you're making new UI components is language. Pay attention to the way that you and your coworkers talk about your application to each other. If there's a graphical interface in your app that everyone on your team refers to by a specific name, often serving as the subject in a sentence, and if by using that word everybody can point at it, it's probably going to be a component that you'll eventually want. These are things like the main menu or the floor plan. It's frequently a good idea to borrow from natural language when choosing names for your components, and natural language can help us in other ways as well, which is why I mentioned it first, even though I actually wouldn't recommend starting with our nouns. In fact, what I would recommend starting with is what changes, when, and why. First, because we want to insulate parts of our user interface that change from parts that stay the same. And second, because that information tells us what our UI components options and how will be and how we might want to interact with those options. And third, because when two elements on the page change together in response to the same thing, it can tell us either we missed a component, or it can tell us, lead us to choose a better component than we might have using another method. So we'll start by using those three that we just covered, and we'll add in a few more techniques, which we'll go into more detail. So when I saw our product for the first time, one of the first things that I noticed was that there was a visual pattern in the overall layout of the site. That's a really useful way to break our application's designs down into UI components. Look for any visual design that repeats, because when there's a part of a design that's highly similar and it's used in multiple places, it's often a good idea to make a component that will represent it. Visual patterns are the adjectives that describe what our graphical interfaces look like. Things like square or blue. But note, you need a combination of specific adjectives. If you're creating a component just for blue, you've gone way too far. However, visual patterns are almost never 100% identical. In our site layout, sometimes the header will have one or more dropdowns, and sometimes it won't. Sometimes the menu will have navigation in it. Other times it will be present but empty, and still other times there's not going to be a menu bar at all. So now I know, what parts of this design repeat visually and what parts change, which you'll recall tells us a lot about what options we should have and how we need to interact with those options. You may have noticed that this whole time I've been implying the existence of a UI component that intrinsically has 3 parts. And why? Why would I say that this whole thing is one component with 3 insertion points instead of 3 separate components? The first and most important reason is another thing to keep in mind: technical limitations. There's a need to let technical limitations help us make the right choices about the design of our UI components. That can happen in a variety of ways. And in this case, this layout needs to have a body that always fills all available space in the viewport, even when there's very little content, minus whatever space is occupied by the heading and the menu. Also, when it scrolls, the body has to scroll relative to the header. The most reliable and arguably intuitive ways to have this content area fill the space with CSS requires these elements to be siblings with a parent entirely under my control. And the only way that I can guarantee that nothing in that outline will get changed, added, removed unexpectedly is if I control all of it in the UI components template. Also, if I choose to make each part of this its own directive, I haven't really gained much. All I've done is reinvent HTML without adding any significant value. It would be just as easy to copy and paste the vanilla HTML as it would be to copy and paste those directives. This could make sense, but only for something that's providing a lot more complexity than just a basic site layout. So instead, we'll use a single tag and assume that we're going to pass our content in as HTML, since there's so much that can be different. We'll call that tag site, because we'll be using it for all guest center sites, and we're saving app for later. And of course, we'll make sure to meaningfully prefix it to prevent conflicts in our HTML shared namespace, so it becomes OT site. And I think that covers all of our requirements for site. So now we'll move back to Kara, who will implement the site layout component in Angular.
Okay. So now that we've begun to discuss the interface for OT site, let's start thinking about how the component user would pass their data into the component. So to review, as you can see here, there are 3 sections: the header, the menu, and the body. And each section has to be able to support any type of arbitrary content. So we have to be able to control not just text, but also any underlying structures that might change. Given this, we have a few options for passing data. The first option, and certainly the most ubiquitous, is by using HTML attributes as a component API. So using attributes, you can pass in strings for text that display in different sections of the app. You can also pass in Boolean toggles for switching a dropdown on or off. And it's manageable to pass in data this way as long as you only have a few. But for arbitrary content, quickly this becomes bloated and untenable. This would be terrifying in any application. So instead, we can use a strategy called transclusion. Transclusion, as it pertains to Angular, is the practice of passing an HTML template to a directive by inserting it between the opening and closing tags. That template will then be appended to some part of the directive's internal template while maintaining a connection to the original scope that it came from. Transclusion is ideal for wrapping arbitrary content because it puts the onus on you as the component user to define your own template for your specific needs. So here's an example of using transclusion with OT site. Between the tags, we add our template with our 3 test strings that we're using for now. I'm transcluding the header, the menu, and the body. So given this interface for the component user, we'd want our output to look something like this. We'd want the first string to go into the header, the second to the menu, the third to the body. So how do we implement our directive to achieve this result? Okay, so going over to the directive definition, before we jump into this, you're going to notice that we're using a few features that aren't actually supported in ES5, namely fat arrows and template strings from ES6. So before we kind of jump into this, I'm just going to briefly go over those 2 things so that we're all on the same page. For context, we're using these for the sake of brevity on our slides, just to make sure that everything's clean and easy to read. All right, so template strings, they're similar to normal strings, but they're delimited by backticks. And they allow us to write across multiple lines. We don't have to concatenate in that way that we're doing on the top. And they also support CoffeeScript-like string interpolation, which is demarcated by that curly sign or $ curly brace syntax right there. So instead of having to concatenate it again here, we can just interpolate it. And then lastly, you'll notice that we're using ES6 fat arrows. And fat arrows, like in CoffeeScript, can be used in the place of normal function definition syntax with the added benefit of lexically binding the value of this. So rather than having to do var that equals this all over the place, we can just use the fat arrow and we can simply use this. So we've been pretty generous in our usage of fat arrows in the presentation for the sake of saving space, so take them with a little bit of a grain of salt. Okay, so now that we're all on the same page, let's come back to the directive definition. So we've set up a pretty normal scaffold here. We've named our directive OT site, and we're returning our directive definition object. We've already added an isolate scope, but we'll kind of go into that in more detail later. But as you can see, our template is still blank. So first, let's go ahead and add a template. Okay, so now we have a wrapper div, and we have our 3 transcludable sections, the header, the nav, which is the menu, and the main, which is the body. And then we also have this static footer that we just want to come packaged with our component. It's worth noting that in production, these would all have classes supported by a style sheet, but again, we're going to omit that for brevity. Okay, so since we've set up the template, our output's going to look something like this. So again, it's supported by a style sheet, so we have all 4 of our sections displayed. But if you'll remember from earlier, we had passed in these 3 statements, right? So where did they go? They're clearly not in our output. Well, by default, as soon as you set an internal template for a directive, any content that you pass between the opening and closing tags of that directive is going to be replaced by the template that you set. So that means that the transcluded content that the user is submitting will be overwritten by the internal template and won't be saved. So if you want to save the transcluded content, you actually have to tell Angular in some way that you'll be transcluding. So to do this, you simply set the transclude property to true. And that will save our transcluded content or clone. Okay, so at this point, we haven't actually inserted the content that we've saved anywhere in our directive template. So how are we going to do that? Well, the most basic way to do this is by using the transclusion that comes natively with Angular, which is the ngTransclude directive. And that will handle fetching and appending the clone for you. So what happens if we use ngTransclude here? We have 3 transcludable sections. We can just drop ngTransclude on each section. Let's see what happens. Okay, so that's not what we want. It looks like it appended the entire code block to every section instead of matching each div to its appropriate section. And if you look at the actual source of the ngTransclude directive, you can confirm that it's pretty basic. It's just going to empty the code block and append the entire clone to the current element. So there's no extra processing here. It's not going to match the first div to the first div or anything like that. So in Angular 1.3, this is all that we have. In Angular 2, there's going to be more options for this. So if we want this to work and we want to pick apart the clone and match clone elements to certain elements in the template, we're going to have to write our own customized transclusion functionality. So let's go ahead and remove the ngTranscludes. And let's reassess this interface that we had defined. So hopefully you see now that there is a flaw in this interface. There's no way for the component user to indicate where each section should, or where each div should go in the template. So a quick solution is to add an attribute to each div that works as a sort of shipping label. So we know that the first div should be transcluded to the site head, the second to the site menu, and the third to the site body. And then in the directive template, we can add IDs that correspond to those labels, so that when the user writes transclude to the site head, we know that they need this header tag up here. Okay, so we have the labels and the IDs. So what's our plan for actually manipulating the DOM to match them to one another? So if we're going to go through this quickly. So for every element in the clone, we want to get the target ID for that element. We want to find the target element within the template that has that ID and append the clone element to its target. So let's echo that pattern in code. And let's take for granted for a moment that we have access to this clone variable up here. So if we're looping through every element in the template, we want to look at its attributes object and grab the value of its transclude2 attribute to get the target ID. Search the directives internal template for an element whose transclude ID matches that target ID which give us our target. And then again, append the clone element to that target. So pretty straightforward. So we're done if everything goes according to plan. But what if our component user adds an element but forgets the transclude2 attribute, or typos and their transclude attribute is invalid? Well, then the target's not going to be found, right? So then it's never really going to be appended to the DOM in the way that we expect. So it's not going to be properly destroyed in this case when the scope is destroyed, and this will cause a memory leak. So we have to handle this case. So first, before appending, let's check to see that our target is actually found. So the .find method is always going to return a jQuery object. So here we're checking the length property to see if that object is actually wrapping a real element rather than wrapping an empty object. So if we do find a target, we want to append as normal. Otherwise, if no target is found, we're going to call remove ourselves on the orphaned element to make sure that it's cleaned up properly and we don't create a memory leak. And lastly, so we don't really want to support putting anything without a transclude2 attribute on the DOM at all, because we can't really prevent a bad experience, especially if the directive that they forgot to put the label on happens to have heavy compilation time or something like that. So we should also throw an error. So let's leave both in, so at least the element will be removed in the case that the error is ignored. Okay, so the only problem at this point is we don't know how to get access to that clone variable. How do we get access to it if we're not using ngTransclude? Well, luckily, once we set the transclude property to true, a function called the transclude function becomes available. The transclude function is a special linking function that takes two parameters, an optional scope and a callback function that receives the clone variable. So the callback is where the magic happens. It'll receive the clone variable, so you can do all of your DOM manipulation straight in that callback, and you'll have access to everything that you need. So let's go ahead and wrap the code that we already wrote in that transclude function that we know we're going to need. Okay, so how do we get access to the transclude function? Well, it actually becomes available in 3 different places. The compile function as its third parameter, the 5th parameter of the link function, and as an injectable of the controller. So given that it's available in all of these places, which one do you use and why? Well, a lot of blog posts and articles will, especially outdated ones, will advise you to use the transclude function that's passed to the compile function. But this causes a lot of problems if you use it. So to understand what the problems are, let's first try to accomplish what we're trying to do with this version. So we can go ahead and add our own compile function and paste in the functionality we already wrote. So if we use this version of transclude, it's not going to work quite yet, because the version of the transclude function that's passed into compile is actually slightly different than the transclude function that's passed in the link function and in the controller function. In this version, scope actually isn't optional. You have to pass in the scope that you want to be linked to your clone yourself. The only problem is, if you look here, we don't have access to the directive scope or the proper outer scope. So if we really wanted to hack it, I guess we could inject the root scope and create a child here. And that would create a scope. And it will seem to work, kind of. It won't error, at least. But hacking it this way causes a huge problem. Remember that the scope that we're passing into the transclude function will ultimately be linked to our clone. And the scope that we set is not the correct scope. So for our component to be intuitive to use, it should behave as much like normal transclusion as possible, and this isn't the scope that transclusion would normally use. So to kind of explain the difference here, let's consider the scope hierarchy that we've created using this diagram here. So on the left side, we have a representation of the DOM hierarchy that we've created, color-coded so that every color represents a new scope. And on the right, we have a representation of how the scopes will interact with one another on the prototype chain. So to kind of explain this paradigm really quickly, every box is a new scope, and boxes that are nested in other boxes are inheriting from their parent outer boxes. Okay, so we have our HTML tag, which has bootstrapping our app, so this would create our root scope here. Within that, we have our body tag that has an ng controller tag, so that's creating a child scope for the controller. Within that, we have our OT site tag, which creates an isolate scope, and we'll talk about that more later. And then here we have our transcluded content, or our clone, which we've just bound to root scope.new. So given this DOM hierarchy, what does that actually mean for the way that the scopes will interact? Well, again, we'll have our root scope here. The controller will indeed be a child scope, and the DOM, at least this far, is identical. But once we get to here, you see that we've made our transcluded content a child of the root scope rather than a child of the controller. So the problem is now these are sibling scopes. So we can't reach up the prototype chain from the clone into our controller. We can only reach up to the root scope. So if we want to access the properties on the controller, we don't actually have access to them, so none of our bindings are going to work. So even though it's within, on the DOM, it looks like it would be within the influence of the controller, it's actually not because of the way that we set it up. So this isn't going to work. So if we compare that to the correct transclusion scope, this is the one that's auto-generated by the other two transclusion functions. So the correct transclusion scope is always going to be a child of whatever outer scope the directive was placed in. So in this case, OT site was placed in the controller scope, right? That's its outer scope. So we want our transcluded content or clone scope to be a child of that outer scope. That way, if we wanted to pass in any properties from our controller, we have access to it because it can just reach up the prototype chain and grab it. So how can we change our model to match this ideal model that will give us access to our controller? Well, unfortunately, using this paradigm here, we simply don't have a reference to the proper scope. So let's go ahead and remove it. What we can do if we wanted to continue trying to hack this is we can take advantage of the fact that the compile function can return the link function. And we can go ahead and use the link function's reference to scope to create the correct scope, which is, again, scope.parent, which is the controller, .new, which is the child of the controller. So if we look at our output, given the code that we just, given the code that we just wrote, this will work. Everything will be transcluded fine, but if we revisit the code, you'll kind of see that we have all this unnecessary wrapper code, right? We're using the link function anyway, but we're insisting on using the compiles version of transclude, so that doesn't really make a whole lot of sense. Why don't we just use the link function's version of transclude that comes in as the 5th parameter? Well, let's try to do that. So if we go on to the link version, we can remove this wrapper, just use the link function directly, and the added benefit here is the scope is optional for this version, so we don't actually have to think about it and pass it in. It'll be pre-bound to the correct transclusion scope already. So this is a lot briefer and less to worry about when it comes to scopes. So our output will still be correct, but our code is a little bit cleaner. But you'll notice that there's one more option here, the controller. Would there be any benefit to switching to the controller's version? Well, let's compare the link function and the controller function in the directive lifecycle. So on our timeline here, we're following the lifecycle of 2 directives. We have a parent directive, which is something like OT site, and then a directive that's defined in the parent directives template, something like, well, I guess we don't have that for this case, but let's say that OT site's template had a directive within it. And that we're going to call the child directive. So when are their compile, controller, and link functions going to fire in comparison to one another? Well, first we'll have the parent's compile function that will run, then the child's compile function, then the parent's controller, the parent's prelink, the child's controller, the child's prelink, then the child's postlink, and the parent's postlink. So the difference here, as you can see, is order of execution. These functions are being run at different times. And the controller generally runs for the parent before the controller will be run for the child. Whereas in the postlink function, the parent will be run, or the child's link function will be run before the parent's link function. So generally speaking, you want to stick to the link function for DOM manipulation because it's the safest time. If you're messing around with the children, like we are in this case, inserting and removing children from the DOM, you want that to happen after the children have already been linked. So we want to do it. Here, because if you're messing around with the children before the children are linked, then the compiler linking function might have some trouble finding the correct child elements for linking. So we'll see an appropriate usage of the controller later on in the presentation. So ultimately, the link function is your best bet. So quickly to review, if you use the compiles version of Transclude, you're going to have some scoping issues, for which reason it's actually been deprecated. And if you use the version that is in Link and the controller, it's a little bit safer, and Link is probably your best bet. Okay, so before we move on, I wanted to point out one last big strength of multi-transclusion, which is its inherent reusability. So given that we're building a fully component-based architecture, it's likely that some of our other components might want to have multiple points of entry as well. So to abstract this, we can abstract the transclusion logic out into a service. So if we create a transclude function, we can move all the logic that we previously wrote into here. And then if we go back to our OT site directive, we can remove the logic from here, inject our new multi-transclude service, and call the function that we just wrote. So now with these two small changes, we can rewire any component to use multiple entry points. Okay, so now that we've implemented the site component, quickly let's go through the pros and cons of using this type of model. So on the pro side, it has a really flexible UI. You can wrap any sort of arbitrary content. But consequently, with such an open system, you have a lot less control over how it's going to look. It can look pretty broken if people are using it wrong. It's all one piece, so you don't have to worry about communication, but of course, it's going to require some DOM manipulation in that case. It's extensible because you can add new sections as you go, but its use of attributes makes it feel less like HTML. And as we just saw, it's quite reusable, which is always nice. So with that, I'll pass it over to Rachel to talk about the next component.
So now we've got a viable site component. And what else do we need? Well, I think the navigation probably, because that's going to be pretty important. When I interact with our product, I notice one of, and the last of, our unexplained points from earlier, behavioral repetition. Behavioral repetition is closely related to, but not identical to, visual repetition. In fact, behavioral patterns can sometimes be overlooked due to more or less superficial differences in just their visual design. However, behavioral patterns can be spotted in the verbs that we use when we're describing our graphical interface. When we say the dialog appears or the menu closes, we're describing behavior, and we're just describing how the interface acts. So often, if you have a sequence of behaviors that repeats, you can make a UI component from it. And all of the navigation options have something in common. There's a group of them. When one is activated, it becomes selected, and then some action occurs. When another is activated, the first is not anymore. Instead, the next is selected, and then some other thing happens. So even though there's some diversity visually between our navigation, especially when we start looking at other menus across the rest of our application, there's repetition in the functionality. So if we completely ignore how it looks and we just focus on how it acts, we have one of the most useful components in our library, the selectable list. So what are the essentials of our list? First, we need a set of items. Our actual items change, and that is how we know it needs to be an option. Second, we need to know, or hopefully be told, which item corresponds to the current selection. We also need some way to perform an arbitrary user-defined action, another area of volatility, because while something always happens, what actually happens changes depending on the list. And finally, since we're implementing a list that can be used to build lots of different things, we need some way to specify an appearance. Our visuals and our behavior for selectable lists change independently of each other. We won't actually implement these last two, just due to time, but we wanted to mention them because they're essential to choosing the right design for list. And so Kara will take over to walk you through implementing that selectable list.
Okay, so we have two lists in the app scaffold that we're eventually going to implement, but let's start with the most obvious one, the list of areas and the areas navigation right there. So to build this list, first we need to save the areas data somewhere. So for now, we're going to put it on our app controller. It's worth noting that normally we would wrap this in a service of some kind, but for simplicity's sake, we're just going to put it on the controller directly. So we have an areas object on the controller that contains a list of areas and our current area, which is the floor plan. So if we go back to the markup that we've been working on for our existing application scaffold code, let's plug in our OT list tag the way we'd want to use it. So first, let's remove our old test code and replace it with an OT list tag. And then we can use the interface that Rachel mentioned earlier to pass in our areas.list as our list of items and areas.current as our current selection. And quickly, remember that we do have access to the areas object because we specifically set the transclusion scope for OT site to be a child of the controller. So anything on the controller we have access to. Okay, and in order to use OT site properly, we also have to add a transclude to attribute to add it into one of our sections. And the list will eventually live in the site menu, but let's put it in the body for now because we're going to be comparing multiple lists to one another, so we need the space. Okay, great. So theoretically, with that interface, our list component should work. So moving on to the directive definition object, let's start by defining a template. So the template is pretty straightforward. We have an unordered list, and we're ng repeating over every item in the items list that the user submitted to create list items. And we're using ng class to give an OT selected class to the currently selected item. And you'll note here that we're also namespacing our CSS classes to prevent conflicts. Don't forget to do that. And then on click, we're going to call the select item function, which will select whatever item you click on. So moving on from the template to the link function, we can implement that select item function to set scope.selected, and which leaves us with the question, how are we going to pass the attributes that the user passed in onto our scope? So if we started with the most naive implementation, we might try this strategy right here. The link function does provide an attributes object. Why don't we simply transfer items one at a time onto our scope? So this will work. And if we look at our live version of this, you can see that it does create the list properly with the right data. It does have an initial selection. And if you click on any item in the list, it's selected. So it seems to work. There is a huge problem with this implementation. Back. Which brings us to the topic that we can't avoid in a talk about reusable components, scope. We did not set a scope property in our directive definition object. And the default behavior, when you don't set a scope, is for the directives template to share whatever outer scope the directive was placed in. This means that the scope of the directive is completely vulnerable to its environment and vice versa. So suffice it to say, this is not a good idea for something that you want to reuse. To drive this point home, let's see what happens when we try to build our apps navigation list in concert with our areas navigation list. So again, we want to put the apps list on our controller. And it's set up in a similar way. We just have an apps object that contains a list of apps and our current app. And then we'll add another OT list instance onto our markup. And again, apps.list is our list of items, and apps.current is our current selection, transcluded to the site body. Oh, look at the live version of this. Okay, so if we look at the output, something is obviously off. We put in two separate lists of data, right? But so we'd expect each list to be showing its own list of data. However, they're both showing the same list, this marketing, planning, reservations, apps list. And if we click on anything on either of the lists, both of the lists are going to be affected. So what's going on? As foreshadowed, shared scope is the culprit here. So again, we'll look at our scope diagram. We have our apps controller here, and we put our apps and areas objects straight on the controller. And then we have our OT site tag, which creates a transclusion scope for anything that you're putting inside it. And here we have our items and selected properties. So as we didn't set a scope for our list component, each instance of list is going to be sharing its outer scope. So in every scope, so the OT site transclusion scope here can only have one copy of items and one copy of selected, right? So the first instance is going to go through, set an items variable, set a selected variable. And then the second instance is going to go through and immediately overwrite both of these variables. So obviously this setup isn't going to work because we need to have a way where they can coexist without overwriting each other. And the setup also has another problem, even when you use just one instance at a time, and that's if you happen to put the list component in an environment that already had an items variable or a selected variable, you'd also be overwriting something in your outer app. So not only could a list instance break other list instances, it can also break your app. So obviously we don't want to give a component the power to do that. So we can fix this by simply setting the scope property to true. And what this does is it gives each instance of the directive its own child scope of the outer scope. So each OT list has its own copy of items and selected, so they won't affect or overwrite each other as sibling scopes. So if we again go to our live output, we can see that we now have two lists and their selections are independent of one another. Okay, so this is undoubtedly an improvement, right? So we created a child scope of whatever outer scope the directive was placed in, but it's still part of the prototype chain. So while we fixed any leaks from the list to its outer environment, what about leaks from the environment down into list? Let's say, for example, we wanted to add an optional header to our list, and we only want the header to show if the user passes in a header attribute. And if the user doesn't pass in a header attribute, we don't want a header at all. This would work as long as there doesn't happen to be a header variable anywhere up the prototype chain from list. As soon as you have a header variable, let's say it's on the controller right here, it's gonna be found in the list directive whether or not you want it to be. So JavaScript will look for the header variable in list, it's not gonna find it. It'll look for the header variable up in Transclusion scope here, not gonna find it. And then it'll look for a header variable up in the app controller. It will find it here, and then it will use that header variable, even though it's not the one that you wanted it to use. So even though you deliberately didn't set a header variable on your OT list scope, you're always going to be inheriting this header from its environment. So it kind of prevents you from doing any optional behavior like that. So for our components, we need complete assurance that there won't be leaks in either direction, either outside into its environment or from its environment outside into it. That way we can be sure it'll work in any context. So what we need here is a scope that's completely outside this chain of inheritance. So we can do that with an isolate scope. You can create one by simply setting scope to any object. So what does this do to our scope hierarchy? As you can see, it takes each of these list instances outside of our OT site transclusion scope and really just outside of this entire box. So they're completely isolated from their environments. They're not going to inherit anything prototypically from either of these things. The only variables that they're going to receive are variables that you explicitly pass to them using the scope object. Which brings me to the other benefit of using isolate scope. It allows us to remove this laborious movement of attributes to the scope one by one. We can simply use the scope object shorthand, putting variables or attributes on the right onto the scope with these properties on the left. And if the names happen to be the same, like they are in this case, we can shorten it to just the binding strategy. Which is the last benefit. You can easily set up two-way binding this way without having to worry about adding your own scope.watches. Okay, this also allows us to remove those pesky curly braces because we're using two-way binding. And then we're going to move one of them to the site menu since we're done implementing it. And now if we go to the live example, we can see that everything still works. And obviously we added a CSS class to make this look slightly different. Okay. So now that we've implemented the list component, let's briefly again go over the model. On the pro side, it's a very simple interface. It's really intuitive and easy for people to learn to use. It's also a closed system, so you have full control over how it's going to look. They're only passing in specific toggles that you pre-approve. On the con side, it's not very extensible. You're going to get to attribute bloat pretty quickly, and it's also a lot less flexible because you can only use it in certain ways. So that concludes list. So let's hand it to Rachel for Dropdown.
Okay, so we're almost done with our application scaffold, and there's one final component that we'll walk through. By process of elimination, it's pretty clear the one thing that we have not done, but we'll walk through quickly how we might spot it in a real mock-up. Our header has two navigation widgets, which we've partially completed by making selectable list, but there's some additional visual and behavioral similarity and functionality that we need to address. If you click on the box with the text and the arrow, menu appears. If you were to click anywhere else, the menu would go away. And it might be tempting to create a component that represents just that top box and have it display a list when clicked and just call it a day. But that would be a mistake. For one thing, one of our navigation widgets has a design that actually calls for some pretty distinct content that's not particularly list-like. Or, okay, if it's a list, it's not just one list, because the items in that list aren't ontologically, functionally, or visually identical. But more practically, we have a number of other user interfaces in our application with behavioral similarity, but with varying degrees of visual distinction. And so because of this, I know that I'm going to want to provide arbitrary HTML to my heart's content rather than being limited to just a list. So keeping that in mind, it becomes clear that the component we need is one with two insertion points. The first contains whatever component will invite the user to interact, and the second one will accept one or more components that will appear. Dropdown trigger and the dropdown target are something we can benefit from isolating, even though their contents are highly changeable. And if that benefit is not already apparent, it's worth noting that this particular choice of abstraction allows us to use the same UI component for dropdowns, for tooltips, and for dialogues, just by offering options for theme and transition. Though we won't go that far right away, this UI component gives us more room to grow. It also highlights one of the major strengths of UI components, which is the ability to compose new UI components from existing UI components. So now we'll bring Kara back for some more insight on how we would accomplish this with Angular.
Okay, so for our implementation, let's focus on the apps dropdown first. So if we come back to our HTML that we've been working on, first let's collapse that site menu that we just implemented because we're not currently working on it. And let's focus on this apps list. So we've already created the list that's going to comprise the menu or the target portion of our dropdown. How are we going to embed it into our dropdown? So as Rachel mentioned, it's probably not a good idea to add this list to our internal template because not all dropdowns are going to have lists embedded in their target. So instead, we're probably going to have the user pass it in as a template. And let's also take it out of the site body and put it into the header where it belongs. Okay, so at this point, we have the list for the target section, but we still need the current selection at the top for the dropdown or the trigger. So here we're adding a span that's bound to the current selection of the apps list. Okay, so we have all the parts defined, but since we don't want all the parts to be transcluded into the same section, and given the multiple entry points, you might think that we could use the multi-transclude pattern that we covered earlier. And this would actually work. But what if we wanted to use a more HTML-like pattern and used elements rather than attributes? We could do something like this. That takes advantage of subdirectives. So rather than having a transclude to attribute that's kind of hidden, we could have an OT target that represents our menu or bottom and an OT trigger that represents our top. So there's some advantages to choosing this pattern over multi-transclude. Besides being a little bit more HTML-like and potentially more dry, This pattern also allows us some further modularity. So first, given that we have subdirectives, we can maintain the top separately from maintaining the bottom. And if we want to pass in options for the dropdown, we can also split them up between our separate directives. So options for the trigger stay with the trigger directive, and options for the target stay with the target directive. So given some of the benefits of this pattern, let's start implementing it. Okay, so first we'll add an isolate scope, given that we've established its importance. And we also need to set transclude to true here, because if we revisit our interface here, we can see that there's actually 2 levels of transclusion. We have the dropdowns version of transclusion here, and the transclusion that we're going to need for the trigger and the target. So we've set transclude to true. Let's add a template with a simple div for now. And here, since dropdown only has 1 transclusion point for the trigger and the target, we can use ng-transclude for normal transcluding functionality. And then we can add our click event here to toggle our menu open and closed. So going into the link function, we can implement this simple toggle target function. And it simply will turn this target open property on or off, or true or false. And then we can use this property to toggle the visibility of the menu through an ng-show. Okay, so next we'll define our subdirectives, OT trigger and OT target. And as established, there's 2 levels of transclusion, so each of them also needs to set transclude to true to save the transcluded content. We'll set templates for the both of them to simple divs for the top and the bottom. And then although there are 2 total entry points for this component, each subdirective is taking 1 of the entry points. So for each directive, we can use a simple ng-transclude because we're splitting up the transclusion. Okay, and our OT target here is going to need a little bit of extra functionality because we want it to be showing and hiding. So we'll just add an ng-show here that's bound to the target open property that we created. So given this, let's check our output. Oops. Okay. Oh no. I'm clicking on this very hard. It's not working. So what is wrong with this example? So remember that we're set to ng-show, the target open property. But wait, do we even have access to the target open property? I think it's pretty clear based on my tone that we do not. If we look at our scope hierarchy again, we have our app controller, which is our body tag, into which we put our OT site tag, into which we're transcluding our dropdown, into which we're transcluding our trigger and our target. So quickly, I wanted to point out that you have to remember that every transcluding component has 2 scopes, right? It's going to have the scope for its template, its internal template, which is the isolate scopes here, and it's going to have the template for whatever content that you're transcluding into it, which has a special transclusion scope. So here in the OT dropdown transclusion scope, that's where we put our trigger and our target tags, right? And we didn't set specific scopes for them, so they're going to be sharing this OT dropdown transclusion scope. But the target open property is living here on our OT dropdown isolate scope. So we don't have access to that property, which is why it's not working. So what are we going to do? Well, luckily, if we want to communicate between directives, we can use the controller function to act as an API. So if you put something on the main or parent directive, the controller of that, it can then be pulled down by other directives using the require property. So in your subdirectives, if you require a controller, it'll be serviced to you as the 4th parameter of that subdirectives link function, with the caveat that the controller has to be available on the element itself, or as like another directive of that element, or one of its parent elements. So focusing on the controller side first, in our OT dropdown directive, let's replace our link function, which can't be seen by other directives, with our controller. And we can replace the scope with our injectable scope. And here, we had the target open property on our isolate scope, but remember, the isolate scope is isolated, so we don't want to put it there. We want to put it on our controller. So if we use this, we can get it to be bound to our controller rather than our isolate scope. And remember, we're using fat arrow here, so we can just use this. Okay, so on the other side, on the subdirective side, for OT target, we can add the require property and require OT dropdown. You'll note that we're using the camel case here. And we're also using a caret prefix to indicate that OT dropdown is going to be a parent of OT target. So we're looking for the OT dropdown controller on a parent rather than on the same element. Then in our link, we'll add our controller to the scope using the fourth parameter that's been surfaced. And ng show controller.targetOpen. So again, if we go live, 7, so we can see that everything works. Hooray! Okay. So coming back to this scope diagram, you might have gotten a funny feeling when I mentioned earlier that OT trigger and OT target are sharing the transclusion scope of OT dropdown, given our extended talk about scopes earlier. And you'd be right to be a little worried, because if we decided to add options later to trigger or target subdirectives, we don't want them to be kind of here in this scope soup. We want to be able to isolate them from their environment as well. So what we need to do here to properly isolate trigger and target is to add isolate scopes for this. So if we revisit our scope diagram, given their isolate scopes, now trigger and target are also isolated, and they're not sharing any of their outer scope. So to compare this model to multi-transclude and the attribute passing model, it also has a flexible UI, but with the caveat that open systems mean you don't have any control. You're using natural declarative language. It's very much like HTML, but then you have a lot of boilerplate that you have to write to even get all of your parts of your directive. You can modularize and separate concerns, but you have to write new directives for every new section that you want to add. So that's it for our last component. So on to Rachel to wrap this up.
So we're going to close by bringing everything together and just reflecting on how appropriate component design builds on itself. How you design each UI component affects how effectively it can be used to build increasingly more complex and increasingly useful UI components. We saw this a little when we talked about how making list and dropdown separate things got the same end result, but also gave us two far more flexible components. We built 3 UI components, a site, a list, and a dropdown, which when used together and combined with some user-provided information, create this application scaffold. The code for that is more expressive and accomplishes a lot more in fewer lines than it would have without UI components. But it's still pretty long and is itself boilerplate, which is going to be used by all of our application's interior pages. So how about we create one final UI component that eliminates all that boilerplate? So in guest center applications currently, one tag provides the common foundation for our entire app's layout and for its navigation. And that's how OpenTable uses user interface components to speed future development and to provide seamless but maintainable user experiences.
So quickly before we sign off, we wanted to say thank you to some of our team members that helped us with the presentation. So thank you to Barry, Simon, and Caleb for helping us beautify our slides and our diagrams. That's why they looked so colorful and nice. And then also thank you to Sarah and David for all your feedback and support through the process. So, and to the Academy and everyone else. All right. Anyway, that's it. So thank you.
We have one more quick lightning talk. Victor's gonna do it.
So I will talk about making Angular 2 more suitable functional programming. And most of what I'm going to cover is still in active development. So focus on API. Don't focus on API, focus on ideas and capabilities. But first, let's talk about functional programming. Let me fix my presentation first, and then we'll talk about functional programming. Oh, come on. It's a very advanced. Here we go. So why functional programming? Why do we care? And we care for a few reasons. All right, and we care for a few reasons. So imagine an application being a netted structure of components. So we have components inside components. And imagine that we have the following constraints. Every component can depend only on its bindings and can affect only its direct children. So for example, on this slide, you can see that to-do component points at two input elements, and it should be able to affect only those guys and nothing else in the application, all right? When we have these two constraints, what we get is a wonderful property, which I call locality. And the property is that we can reason about every component in isolation. We don't need to know how it's being used and where it's being used. In theory, we should be able to reason about a component by just looking at its class and its template and nothing else. And we should be able to make changes to a component and do whatever we want to that component without knowing the rest of the system, which is really, really cool. And why do we want to write our applications this way? We want to do it because we want to control change. We want to make change explicit, predictable, and controlled. All right? So this is the goal. And functional programming just happens to be the means of achieving this goal. It's not the goal in itself. All right, I will talk about change detection, what kind of changes we're making to it to make it work better with functional programming. The first thought that I want you to consider is that a mutable domain model that backs up your component actually goes against our goal. And the reason for that, if you have a mutable domain model that backs up your component, and your component does something to that model, changes it, all right, some other component that just happened to point to it may be updated or affected. So it goes against the property of locality. It's not very good. Instead, what we want to do, we want to model our domain using simple data structures, such as simple objects, like record-like objects and arrays, and transform those guys using universal operations, such as map, filter, and reduce. And we can do it already. So this is an Angular 2 example, but you can write similar code in Angular 1, like today. It works. And it works because Angular doesn't force you to wrap all your data into model classes. It doesn't use KVO, it uses dirty checking instead. And I think it's a huge benefit of this framework. What we want to do better is to sort of make this kind of code smoother and take advantage of this kind of code performance-wise. So the first thing we want to do is to improve our support for persistent data structures. A persistent data structure is a data structure that preserves the previous version of itself when it's modified. So basically, it's a smart, immutable collection. Okay, it doesn't change. The first thing we want to do in Angular 2 is to support most exotic immutable collections. So you should be able to use any collection with ngRepeat or any other directive. And we don't want to obviously hardcode this kind of support into the framework itself, because there are so many collections out there, all right? Instead, what we want to do is to make our change detection pluggable. So you should be able to install a plugin, for example, for Immutable.js, and you should be able to use those collections sort of in a very transparent way. The second thing we want to do is to take advantage of the fact that these collections are immutable performance-wise. We know that those collections don't change. So if I point to an object, I can do a simple reference check instead of a very expensive content check to see if the collection changed. So it can actually be much, much faster to use such data structures instead of arrays or like objects or maps. Here we go. All right. Next thing, which I think is pretty cool, is that we are thinking or we're implementing we're giving you more control over change detection. And I think it's related to functional programming for the following reason. When you use functional programming, you tend to have your changes more explicitly expressed in the code, so you sort of see what and when changes, all right? And before that, you couldn't use this knowledge, even though you knew that the component will never change. Yes, we still would run dirty checking for that component and all its children, which is kind of like unfortunate. Now you will be able to use this knowledge and disable dirty checking for a component altogether until a certain event like arrives. For example, if you use observable objects like RxJS, and your component depends only on observable objects, what you will be able to do is to disable the dirty checking of the component and its children altogether until one of the observable objects fires an event. Or if you use the flags pattern, you will be able to disable the dirty checking of your component altogether until the store fires an event. So you, again, will get a lot of performance benefits. Here we go. Those are the changes that we are implementing in data check and to make it more like functional programming friendly. Another group of changes we are working on is handling input and forms. Because our applications are not just projections of immutable data onto the DOM. Yes, we need to take something back and process those events. And right now, the current way of doing it is using ng model, or the primary way of doing it is using ng model, which works, but I don't think it's the most elegant way of dealing with input. And for the following reason. ng model needs mutable objects. All right, so if the do here is immutable, so for example, frozen, it's a frozen object, we won't be able to use ng model in this setting. It just won't work, which is unfortunate. So it forces us to have mutable components. We have to copy all the properties from our mutable object onto a component. Then we sort of change the component in a very implicit way, and then we sort of reassemble the object back. All right? It works, but it's not elegant, and we can do much better than that. A better way to dealing with input is to treat your forms and your input as streams of values and model them as streams of values. If you do it in this way, you can express complex interactions in a very declarative way without having any state. For example, here we have a form with two fields and two filters, description and checked. And here we have a form that sort of models that HTML form. And we are saying that every time somebody changes either the text field or the checked field, we are going to wait for 500 milliseconds, and then we're going to fire an event and filter the to-dos. So we can express the whole interaction in a somewhat declarative way without having any state. This component is completely stateless, which is good. What we can do also, we can get the current value of the stream of values or the current value of the form. So we can construct a form, and when somebody clicks on the form, we get the value of the form without having to store those individual fields on our component, which allows us to make a huge chunk of components that are mutable right now immutable. All right, so those are the changes that are coming to input handling and forms. I think it's super exciting, and I hope it will help us write more predictable and controlled applications. All right, this is a lightning talk, so that's basically it. You can check out slides if you go there. You can message me on Twitter or talk to me today, and I will answer your questions, and we will pause the slides. Yeah, here we go.
My question is to Victor. You showed out. You mentioned immutable JS for to gain referential transparency and all of that for purity. What about the immutables, the stream of data? I saw like there was an FB there. Is there any like RX or functional reactor programming library that you were using there? There was like an FB there or something.
So basically, we're thinking to make it like RX compatible, but because we're targeting both JavaScript and Dart has its own RX-like library, we're sort of deciding what to do about that. But I mean, potentially it would be basically an RX stream, an RX observable. So form would be an observable.
Hi, my question is for Kira. Yes. Usually when I work with AngularJS, I like to use directives when I'm gonna use more than once. So I saw that you are creating a directive and it will be used only one time. So what would be the benefit of creating a directive will be used only once?
The directive may be used one time on one app, but we mentioned at the beginning that we are making basically every feature its own app. So we'll have 10 teams that are working on, an individual app. Each one of those apps uses OT app one time, but OT app is reused across the 10 apps. And that's really, really important for us to ensure that all of that navigation remains identical and that we can control it, do any bug fixes that need to be done. So while, again, one app uses it one time, we've got lots of apps.
Yeah. That.
Do we have more questions?
Have you run into any kind of uh, difficult situations while debugging these multi-transclude scenarios, because I saw a lot of nesting and nesting of a transclude and transclude and transclude. And I imagine that at some point you're going to run into these really nasty transclude multidimensional bugs. So have you run into any of these, and how do you debug them?
Okay, well, the trick is if you set up your transclusion correctly, it's going to work kind of intuitively how you expect. So if you set your, like for the site scaffold, you're setting the transclusion scope to be a child of the outer scope. So your tree or your prototype chain all the way down is going to be grabbing everything up the transclusion scope, if that makes sense. So you're always going to be able to pass in the things that you expect. But it is complicated. So a lot of times it helps to draw scope diagrams and just like, orient yourself that way.
Okay,
So,
so you have to be super organized while using transclude.
I mean, I think it's important to understand the internals really well and to draw if you need to, but if you set it up the right way, you shouldn't really ever have to think about it.
Okay,
So,
thanks.
Right. It's really the multi-transclusion part that is difficult, and that's something that would usually more senior in a team do, or somebody in the community creates a reusable component. And once that component is done properly, then anybody who's using it doesn't need to understand the complexity behind the component. So as a user, you don't really need to know what's going on behind the scenes because it will just work properly.
right.
You mentioned that before you came across this solution, you explored things like you mentioned polymer, and we also have other kinds of reactive libraries such as React. So my question is, why would you still stick to your own solution instead of using any of other those libraries?
There's a few reasons. One was that we were already using Angular, and what we were focused on actually was because we were not ready to use web components in production yet. But what we wanted was to work through it as if we were using it, which since we were already using Angular, we could do with Angular. We could play around with the custom elements. We could play around with, the concept of, disconnected document fragments by using isolate scope. So that's really the major reason was A, because we were already using it, and B, it allowed us to experiment with things that we knew were going to be good lessons in the future right now.
Regardless of whatever we end up using.
Sorry, just to add something to that. So we had built a very complex application. And then what happened is we started up another place where another part of the application, another team grew it. And this shared thing was incredibly painful to change and deploy simultaneously between these two places because we had different teams. And I mean, this is our navigation between those two things. And you'd push a deployment and you could get to it, but you couldn't get back because the headers were out of sync from each other. So regardless of other frameworks, this was kind of where we were at the time, and we had a lot to explore about just how to break that out. And it didn't make sense to turn around and just throw everything out, because when you're making paradigm shifts, you want to be incremental. And in general, in software development, like, we can't take 6 months and be like, we got it wrong, we're going to start all over. And also, that header that you guys just saw, I literally have a design team that's reworked some of the UI of it. And so while functionally what you saw is kind of the functionality, it's about to get reskinned. And so what we really needed to do as fast as possible is take out the code duplication so that the UI team could actually repackage it and represent it as the design iterated without us having to go completely back to the drawing board. And like she said, once you do that, then you can potentially deliver different parts of your application, even via different, mechanisms. But for now, that was kind of how we took that on.
So when you build components, do you have a need? I'm sure OpenTable is used across a desktop and a tablet. So is there any specific things that um, you added to the component so that it worked across both of these, and you don't have to write a whole new component for it to work on the tablet?
Yeah, it's kind of interesting because the part of the site that we were prioritizing to turn into components first actually did not have any responsiveness to it. So the new design will be adding that responsiveness. We didn't really have to change anything. The only gotcha that we had to make sure of was, properly handling touch events for tablets, which we were already doing. So we're going to actually be kind of going a lot deeper into that in the next couple of months. So I'm really looking forward to what we find out there.
Hi, this question's for Kara. It looked like in some of your examples, basically what you were showing the transclusion with content, right? So I think it's safe to assume some of that content's going to be coming from an API call. So the question is, are you doing the API calls at a parent level, and then basically getting all your content from your API calls at a parent, and then letting the content cascade down?
I mean, currently in the way that we're using our site scaffold, we don't have API calls for that. I mean, for things that are completely static, like our apps list and our areas list, we just wrap that in services and have that locally. But so your question is if you were to grab that from an API or, oh, like the rid list. Okay. Well, that's something that we're currently working out. But so right now we're using we have services that a lot of our components depend on, and we'll have like a login server or something like that, and it will make the API call once and then cache it, and then all of the components will kind of use promises to grab from that API. Is that your question? Yeah, okay.
Yeah, because kind of what I was going to ask to build on that is, obviously another option is instead of doing your content at the parent level, this is kind of where I was getting at is, have you guys looked at doing your API calls, the service calls down actually in the component? So you're just passing in one ID and then the component does everything on its own.
Right. So our the drop downs right there, like those would be the level that the API calls were being made, and then it would all kind of share that state.
So one thing about the scaffold is it's translated across multiple, like we have French and Spanish and Japanese versions of it. So one thing we're talking about is actually creating a translation services and resources via CDN, and then these components would independently call and grab their translation version. So similar to what you're mentioning. So that's something that's kind of on the horizon for us because we want every package. So if we introduce a new language, we don't want to redeploy all sorts of stuff. So we want it to just be able to say, give it to me in this language. And even the supported language list needs to be coming to every component via an API call. So definitely those things are absolutely necessary and kind of how we expect our application reach to grow without wanting to constantly rebuild and redeploy versions. So yeah.
Okay, so the second question was about because of the shadow DOM and things like that, how are we using CSS to kind of?
So we really tried to not mention that because I could do a whole talk just on that. It's really interesting. When I was playing with Polymer, I found that there were things that I really loved about the encapsulation and also things that I really hated. So I was really looking forward to being able to use like a BEM style architecture within our components and still get some cascading inheritance. And that's what we're doing is basically each component has JavaScript associated with it and then Sass associated with it. And we're following very, very closely a modified version of BEM architecture. And we actually have, again, could be a whole nother thing. We also built some directives that help us use BEM architecture in a consistent way across all UI components. So basically what we do is we envision each thing, as its own root, but it's not its own root. It can inherit stuff in. And so you still end up with the same potential bugs that you could get anywhere. But, even with Shadow DOM, if someone does a deep selector, well, you can never get around it, I think.
Can you repeat the first question?
Right. So the first question was what schemes you guys are using for inter-component communication.
Right. So I think that depends a lot on the nature of the communication and kind of how they interact with one another. So we showed kind of one scheme of communication, which was using the controller. So that's a great way if it's kind of connected to your DOM. Like if you have, you want your component to only be communicating with a controller that's some level above it, right? So that's one way to do it. Other ways that we've done are kind of like what we talked about earlier with the API. We'll have some sort of shared service that a bunch of our components depend on. So you can do it that way. Or sometimes when you're really thinking about communication between different components, you also have to think about, like, does this imply that maybe the components should be more related in the beginning? So it kind of depends on your specific case, but grand overarching. It's going to be case to case.
And I get the feeling that we're actually going to try to avoid it as much as possible. And if two things actually do need to talk to each other, like sort of, yeah. I would just kind of bring them into maybe a third component of which those two are children. And then, if there's any bus, it would be more self-contained.
And there's various patterns that kind of make that less necessary, right? Like multi-transclude, and if you're using subdirectives, you're kind of already simplifying that way.
Yeah, and another thing is, like, we're not really using events all that much. We're relying heavily on callbacks for almost everything so far. So,
Okay, one last question.
Hi, Carl. So the components you just presented, are they available on GitHub repo? Are they open source?
they're not. They're not open source yet. Technically, they're not open source yet.
So
but we'll be sharing the code, absolutely.
The slides and the code.
Yeah.
We'll have code examples.
Yeah. And we do plan to, I think, eventually open source some of the UI components that we create.
right, do you
just-
plan to make them like UI bootstrap? Make some
I
components?
don't know. We'll have to see. Right now, we are lucky in that our scope is small enough where we're only doing one design. We do know within the next quarter or two that we will have to support multiple designs, not just guest center designs, but other internal stuff. And we'll have to decide then exactly how we're going to deal with swapping out, everything about the styles. However, I don't think that we would use like Bootstrap framework, most likely.
Okay, thank you.
Okay, Rachael, Kara, thank you very much. Victor, thank you.